Hello, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to look at the file command, which allows you to determine what sort of file you're looking at. In some of our previous investigations, we have encountered some malware. Some of it was web-based, and we've kind of gone through that a little bit. But I wanted to have a look at some of this compiled malware, and we will start looking at that with this video. And in particular, what we're going to look at first is whether or not the thing you're looking at is malware at all. So how can you look at a file that you don't know what it is and try to figure out, okay, this is an executable, what kind of an executable is it, etc. So that's what we're going to start with right now. So the first thing that you can do is you can use the file utility. Now, Linux is much smarter about handling files than, say, Windows. Windows is pretty dumb about how it handles files. It just says, hey, what's your file extension? And it looks it up in the registry and it says, oh, you must be this. And that's often a way that bad people can use to hide information from others. That doesn't work in Linux because Linux is much smarter than that. It actually looks inside the file to determine what sort of file it is. And the file command is used to export that functionality to the user. So basically it works like this. I can just run file against any file. Now, what I have here is a couple of dump files from my memory analysis of the PAS2 subject system. So if I run file against either of these memory dumps, we'll start with the drop bear, it will give me some information, and it tells me that this file is an ELF 32-bit LSB executable. ELF is an executable and linkable file. It's 32-bit with least significant byte endiness. It's little endin. And it's made for the Intel 386 platform and higher. It is a sys5 file. It is statically linked. It doesn't require any DLL, and it's also been stripped. So it's been stripped of debugging information, which will make reverse engineering this particular file more difficult. I can run this command on another file, another dump. So I'll run it on the Xingxi Quan dump. And when I do that, it comes up with something slightly different. This is an ELF 64-bit executable, and it is dynamically linked. And it tells you right here in the comments. That means that it uses shared libraries, which would be called DLLs in the Windows world, and it is not stripped. So that means that this will be a much simpler thing in order to investigate with our debuggers. To give you a couple of other quick examples of using the files command, I'm going to go ahead and go back to our subject system. And here's something else I wanted to show you. Just how good is this? So if I do a file command on things in this directory, I can just say file star. You'll notice it's smart enough to say the README file is an ASCII text file. This is a 64-bit executable. And this is a C source file, which is also ASCII text. We have a couple of directories, etc. So if, for example, I go to one of these directories and I rerun my file command, you'll see that I have C source files, executables, and for the executables, I get some additional information. This is marked as an executable, and it's actually a relocatable kernel module. That's what this KO stands for. And it's telling me that it has a build SHA-1 hash of all of this stuff right here. So it's giving me this information. What this information is used for, this information will tie together a executable of some sort, and it doesn't matter if I build a debugging version of this executable or if I build a release version of this executable that's been stripped, etc. It will still have the same SHA-1 build hash. which is very convenient. It allows me to correlate two things that would definitely have a different hash value if I look at the actual executables. So that is using the file command in order to look into various unknown files. If you just don't know what they do, this is a great starting point. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.